In this video, we talk about solving questions using Laplace transform. The process of Laplace transform can be quite complex if you're starting from scratch. But for the purpose of this module, we are giving you in the formula form of the basic Laplace transform lookup tables. The mechanism of solving a question is actually quite mechanical, and there are three simple steps. First, you transform everything in your equation from the f of t land to the f of s by using the lookup table as well as the Laplace transform of derivatives formula. And then once you have done that, you can get an expression of f of s by rearranging the transformed expressions that you obtained from step one. And after you've got f of s, look at your Laplace table again on the right side, pattern matching to find what fs would correspond to ft. Therefore, get a solution of ft, solving the differential equation. Okay, so let's have a quick look at one example. I'm going to do the first step, which is using the lookup table and the formulas to transform everything in the equation. So f of t, f of prime of t, the first derivative, is going to equal this piece. So I'm just going to copy that down. I'm going to use blue for my s, because otherwise it looks very much like a 5. So I want to avoid any silly mistakes like that. Now, minus 2 f of t, so Laplace transform of f of t is f of s, so that makes 2 f of s. On the right side, I have to find a matching transform for 6e to the 4t. So 6 is just a constant that stays in the front. E to the 4t, I pattern match here, e to the minus kt. So that must mean my k here is a negative 4, because minus k makes a minus minus of a positive 4. So my Laplace transform of e to the 4t, therefore, is 1 over s plus the k, which we just said k is a minus 4, so s minus 4. So that's the first step. We do need to include, after that, include the initial conditions, so that the only things left in the expression is f of s and numbers and the variable s. Okay, so substitute the initial condition into the equation. I'm actually going to be lazy here. I'm just going to copy paste the whole thing. Copy and paste, and substituting in the f of 0, which is a number 3, like that. Okay, second step, we're going to obtain the expression for f of s. So I want to move everything related to f of s to the left side, and everything else to the right. So s times f of s minus 2 f of s equals 6 s minus, let's just keep s in black, s minus 4. And this minus 3 here, I don't want it to be on the left side, so I'm going to move it to the right side, which becomes a plus 3. Now, taking out the common terms of f of s on the left side, and in brackets, I have been left with s minus 2. Okay, the right side is 2 terms, which make it a bit complex when I have to do a divide the brackets of s minus 2. So I'm going to simplify the right side first. So copy down the fraction And number 3, to write it in the fraction, is just 3 times the denominator, then divided by the same denominator. So 3 times s minus 4 divided by s minus 4. And now I can add the two fractions together. S minus 4 as the denominator. And on the numerator, I should have 6 plus 3s and minus 3 times 4 is 12. Okay, and that gives me s minus 4 on the denominator, and on the top I should have 3s, 6 minus 12, keep s as blue. So that's a negative 6. And then you can see that I can further simplify it by taking a common factor 3 out. So 3 goes in the front, then I have s minus 2 over s minus 4. Okay, so I'm going to copy the left side again, like so. So if I now divide both sides by brackets s minus 2, I should obtain an expression for the f of s. So f of s now equals to 3 s minus 2 over s minus 4. Now divided, which means the s minus 2 goes on a denominator. So s minus 2. And we're lucky here that we can cancel a common factor brackets. S minus 2 is on the top as well as on the bottom. So that cancels out. Then my expression for f of s is simply 3 over s minus 4. Okay, so that's my second step done. You need to be quite familiar with rearranging subjects. For here, we're trying to make f of s the subject. So as long as you can have some algebraic manipulations and obtain an expression for f of s in terms of s, then you are nearly there. Okay, so last step, we're going to look at the Laplace transform table again and pattern match the right side, and therefore we can get back to the left side. So my expression 3 over s minus 4 looks like the second one here, s plus k. So 3 again is a constant that can stay in the front. So therefore my f of t is going to be 3 times whatever is matching a 1 over s minus 4. So if I have this pattern matching that, that must mean my k is a negative 4, because then that gives me the negative sign here because it's s plus k. So going backwards then, from this table 1 over s plus k on the f of s land to f of t land, I should have e to the minus kt. So e to the minus, and k is minus 4, so minus 4t. And therefore my answer is 3 times e to the minus make a plus. That makes 4t. So that's the final answer for the differential equation. And that's that question done. If you got time or unsure and really want to check if that works, you can just put that into the initial equation and check if it's satisfied. So the fourth step is kind of extra check step. You want to find out whether f prime of t minus 2 f of t actually equals 6 times e to the 4t. So f prime of t, if f of t is 3, e to the 4t is going to be 3 times the exponential's derivative is itself, but there's an inside function 4t, so that has 2 times 4. So that is 12 e to the 4t. Now, if I plug that into this original expression, the left-hand side, therefore, is 12 e to the 4t minus 2 times the function itself, so 3 e to the 4t. That will be 12 e to the 4t minus 6 e to the 4t, therefore I should have 6 e to the 4t. And that happens to equal to the right-hand side. So that expression is satisfied. We should also check the initial condition. So f of 0 equals 3. So our f of 0, if you plug it into the function, is 3 times e to the 4 times 0. So anything to the 0's power is 1, so that is 3. So both conditions are satisfied. If we have the expression, a functional form of this, both condition of the equation as well as the initial conditions are satisfied. So we know that our answer is watertight, absolutely correct. Okay, thank you for watching.